Alright guys, welcome in. Chemistry 2 final review with Mr. Aragon. I'm going to be going over the first and second page in this video, and then I'll be making a second video on the third and fourth, and then I will be making a third video on the fifth and sixth pages, and then I'm not sure if there's a seventh page, I don't remember, but we'll find out. Alright, cool. Please make sure you guys have your periodic table of elements out. I do not, unfortunately, so for some of the problems in the later end of this video, I'll have to pull up one and I'll take a brief pause, okay? Sweet. Alright, here's the first thing I want you guys to do. This portion over here just really doesn't make any sense because the questions are really asking you about these right here. So, the question's asking you, Unit 6, Bonding and Nomenclature, what are the total atoms in this molecule, right? And so, for aluminum, if you guys notice, we have 2 atoms of aluminum, so I'm going to do a 2 there. For carbon, we have 1, but keep in mind you have this ninja 3 over here that's sneaking over, so you're going to distribute this over here. 3 times 1 is 3, so you have 3 carbons. Plus, you also have 3 times 3 oxygen, which is 9, and so the total number of atoms is going to be, what is that, 14? Can you guys see that? Yep. Why, I don't know why I'm asking you. Alright, perfect. Let's move on to this next one. This one's a little cumbersome to read. Alright, so let's first count how many carbons we have. That'll make us simpler, right? So we have 1, 2, 3 carbons, so perfect. And then let's count how many hydrogens we have. So we have 3 here, 2 here, so 3 plus 2 is 5, plus another 2 is 7, plus another 1 is 8, so we have 8 hydrogen. And now let's look at what's left here, our O's. We have 1, 2 O's. So, if I do 8 plus 2, that's 10, plus 3, that's 13, so we have 13 atoms in that particular molecule, which is fun, because if you look at this molecule, it almost seems like there's more atoms in this molecule because it's much longer than this molecule right here. Alright, that's enough of that. Let's move on to this next one. Let's do the same thing. Let's count the carbons first. We have 1, we have 2, but keep in mind you have a 4 in here, so this is going to be 4 times 1, so this is going to be 4 plus 1 is 5 carbons. Okay, let's do the H's, so we have 3 H's over here. I'm going to write that down, 3, and then we have 4 times 2. Yep, you guys can see that. Alright, perfect. 4 times 2, it's going to be 8 plus 8, and then we have 3 hydrogens over here. Let's see, what is that? 14? So you have 14 hydrogens, and then how many N's do you have? Well, you just have one lonely N by itself, right? So plus 1. So that's going to be 14 plus 1 is 15, plus 5 is 20. This last number is 20, right? If you guys have any issues with that, please, I'm not entirely sure if Miss Nguyen's going to be there with you guys on Monday, but if she is, just ask her to give you a brief rundown on how to analyze and assess how many molecules or atoms there are in this sequence. All right. Let's go back to quarter 1 here for a quick second. This is a sweet table that's comparing ionic bonds versus covalent bonds, right? And so, if you look at the valence electrons for ionic, remember I am very selfish, right? And so, when it comes to valence electrons, they all want 8, right? And so, ionic is selfish, so it's going to transfer electrons. Right? But covalent, meaning like cooperate or work together, you're going to share them because you're a nice guy, right? If you're covalent. Conductivity when a solid, so ionic, think of a metal and a non-metal. They usually conduct electricity, so yes, it conducts electricity. Covalent, not exactly all the time, right? Let's see, conductivity when dissolved in water or aqueous solutions. I'm going to say yes for this particular one, and then I'm going to say no. There are some exceptions. I'm going to explain that a little bit later in a different video. Okay. High melting point versus low melting point. So a covalent, remember, is a bond between a bunch of nonmetals. So think of sugar, like C6H12O6. Right? And so that's sugar. And then think of ionic as like a metal and a non-metal, like salt. So which one has a higher salt melting point? High melting point, yes, for anything that is ionic. Low melting point for sugar for the most part. So I'm going to put no. Bond strength, strong, weak. All right? If you have table salt, in order to break table salts, you need a whole lot of energy to break that down. In order to break sugar down, not a whole heck of a lot of energy. How do you know if a compound is ionic or covalent? So, well, typically, let me scooch this up here. Focus. There we go. All right. Perfect. Typically, if it's ionic, it's a bond between a metal and a non-metal. Metal, non-metal. And then here, if it's covalent, it's a bond between a non-metal and a non-metal. Awesome. Perfect. And then, so explain why NH4Cl is considered an ionic bond even though it does not contain a metal. Well, a second definition of ionic is opposite charges attract. So if you're looking at Na has a -1 charge, and then plus Cl has a, Na has a +1 charge, Cl has a -7 charge, right? And then, so if you're trying to, Cl has a -1 charge. I'm reading a periodic table upside down, sorry. So Na has a plus charge, Cl has a negative charge. They combine because they have opposite charges, right? And now if you look at this molecule here, even though Cl has a negative charge, H has a plus charge. So therefore, even though they're not even though hydrogen is not a metal, it still has the opposite charge to Cl. So that's why we consider that a ionic compound. Cool. All this fun stuff here is just formulas for you guys to kind of peruse through. Please look at this at your own discretion. I would definitely look at this one. The mole is a number. The mole number is 6.02 times 10 to the 23rd. And that's also Avogadro's number, not to be confused with avocado. All right. Molecular weights. For an element, it's the atomic mass. For a compound, you have to list the elements. So if I said, what is the molar mass of sugar, right, which is C6H12O6, I know that I have carbon, but since I have 6 of them, I'm going to have to multiply its atomic mass, which is found on the periodic table, by 6. Same thing with hydrogen. Luckily, it's just 1. Same thing with oxygen, and then so on and so forth, right? All right, let's flip the page. Awesome. There we go. All right. So what is a mole in chemistry? It is a unit of measure that equals 6.02 times 10 to the 23rd, right? This measures the total amount of particles, atoms, or units in 1 mole. Now, explain what Avogadro's number is and what it is used for. Avogadro's number is 6.02 times 10 to the 23rd, and that equals 1 mole. Plain and simple. All right, so here we go. Does 1 mole of NH3 and 1 mole of O2 have the same mass? No, that is not true. Because if I have 1 mole of NH3, N has an atomic mass of, I believe, oh boy, where am I at? 14. H has an atomic mass of 1, but since I have 3 of them, I'm going to do 3, right? And that's going to be NH3 has an atomic mass of 17. Now let's look at O2, right? O has an atomic mass of 16, but since there are 2 of them, it is 32, right? And so 32 is greater than 17, so therefore they are not equal to one another. There we go. Awesome. Do they have the same number of molecules? This is yes, right? And so if I have 1 mole of anything is equal to 6.02 times 10 to the 23rd. That could be molecules, that could be particles, that could be atoms, right? Perfect. Awesome. All right. Now, let's calculate the molar mass of each of the following compounds. Let's see. I'm going to hit the pause button for a quick second. Awesome. All right. Welcome back. Perfect. So, what is the molar mass of each one of these molecules? Well, let's go with the letter A. So we have magnesium. Now, magnesium, if you look at the periodic table of elements, has a molar mass of let's see here, 24.305. So I'm going to do 24.3 plus oxygen, right? But since you have 2 oxygen here, oxygen has an atomic mass of 16 times 2, it's 32, right? And then hydrogen has an atomic mass of 1, but since you have 2 of them, that's going to be 2, right? Plus 2. And so you kind of add those together, and that's how you would find that. Let's move on to iron chloride. And so let's do that.
Are you a big coding boot camp by chance?
All right, let's go back. So we have iron has a atomic mass of, let's see, where are you, Mr. Iron? 55.8. 55.8, right? Plus chlorine, but you have 3 chlorine, and so chlorine has a mass of 35.5, I should say. So you're going to do this plus 3 times 35.5, right? Whatever that is, I don't have a calculator with me, guys, so you guys can figure that out, right? Now let's, ooh, this one's pretty nifty here. All right, so let's look at the, what is this, ammonium sulfate? So let's do the N's first, right? N, you have 2 of them, so that will be 14, I think, times 2 is 28, plus, yep, you guys can see that, all right, perfect, plus 2 times 4 H's, which is 8 H's, so that's 8, plus you have 1 S, which is 32.06, so we'll just do 32, plus 4 oxygen, so you're going to do, I think that's 64. Please correct me if I'm wrong. You obviously can't do so in this video because you're not here, but let me know when I see you guys next. All right. Let's do this last big one here, just for funsies. Let's see, carbon has an atomic mass of 12, so, but since you have 2 of them here, that one and that one, 12 plus 12 is 24, plus you have 3 hydrogens, plus this guy right here, 4 hydrogens, plus 4, plus 2 oxygens, which is, what is it, 16, 16, 32? Perfect, so you're gonna add all these up, and that's your molar mass. Awesome. All right. So let's move on to this last one here. It's gonna give you a little taste of mole conversions before we just dive right in. So what is the mass of 1.6 moles of aluminum sulfate? Now, I always hear you guys say this over and over again, which is a fantastic way to start. You always start with what you have, and then you're trying to get to something else, right? And so I start off with 1.62 moles of aluminum 2 SO4 right, over 1. And if I have moles up top, I'm going to need moles on the bottom to cancel out of moles, right? And so I'm going to have 1 mole of Al2SO4 and I want mass up top. Mass is written in grams, right? Let's not forget that. So grams of aluminum 2 SO4. Now, what goes in here? I'm running out of battery, I believe. Oh boy. What goes here is going to be the molar mass of aluminum 2. So you're going to have to look at aluminum 2, add that to what the molar mass of sulfur is, times 3, plus 4 times 3 is 12 oxygen atoms. And so that number goes here, and then you just multiply across. Okay? I'm going to pause. Actually, I'm going to end this video, and then you'll have a next one coming right up.